In order to do a little bit more with trapezoids, we need to review the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. A and b are both the legs, and c is the hypotenuse, which, if you recall, is the side opposite the right angle. In this right triangle, 6 and 8 are the legs. We need to find the hypotenuse. 6 squared plus 8 squared equals x squared. 36 plus 64 equals x squared. 100 equals x squared. Take the square root of both sides, and the hypotenuse x equals 100. Oh, 10. Just kidding. In this next question, the legs are x and 2, and the hypotenuse is 5. X squared plus 2 squared equals 5 squared. X squared plus 4 equals 25. To find one of the legs, you have to subtract the square of the other leg to the other side. X squared equals 21. Take the square root of both sides, and x equals the square root of 21. Sometimes you might be able to simplify that square root, and sometimes you won't be able to. Now here we have a trapezoid. This is a little bit new for all of you. We have one base as 6 units. The other base on the bottom is 12 units, and the height is 4. Now this is not drawn to scale, so we're not counting boxes. The rectangle inside has a length of 6 and a height of 4. We need to find these two little sides of the trapezoid by subtracting, and we find that they're 3. And now we have a right triangle with legs of 3 and 4. You need to find the hypotenuse, which is the square root of 25, which is 5. We could do so many things with this. We might finish here. We have found that the legs of this isosceles trapezoid are 5. We might even be able to find the perimeter as well. The height is 4, which we don't need for the perimeter. Base 1 is 6, base 2 is 12, and the legs are 5. If we add them all up, we have the perimeter of this isosceles trapezoid, which is 28 units. So now we've taken a trapezoid and we've used the Pythagorean theorem to help us solve some problems. That's what we're going to be working on next.